Exactly. So hopefully line of best fit and correlation is going to be fairly easy for most of you. It's going to be a matter of making sure, one, you can do it algebraically, which I've been watching a lot of the videos and things to post, you guys, but it's really not necessary. And usually if it is an algebraic one, it's going to be pretty easy. So if you remember all the things you know about linear equations in general, just like your slope and your y-intercept and things of that nature, it shouldn't be too hard. But I have not seen these on calculator inactive. I have only seen them on the active section. So you have a calculator and you have Desmos. So both are options to get the line of best fit and to make your predicted values. Understanding what it predicts, that part is on you. So if you're running into questions with that, just let me know. I will flood you with resources and over talk you to death if you let me know that's what you need. But so the line of best fit is just the line that most closely fits a scatter plot. And I will say now that I'm teaching a scatter plot, they gave us 2 lines of the data. I will say that in Math 1, you're only dealing with linear. We're really focused on lines, but in your future math classes, you will do quadratics and exponential and all the fun types of functions. This can work for those. So if you use a ruler, the idea is that you are going to draw a line that is going to most closely touch the most number of dots and have the same amount above and below it is your goal. And so mine's a little skewed probably to the right because off the dots. But the idea is there's about 2 above it and about 2 below. And they're pretty equidistant from that line. Now, when you have a huge bundle of dots, it's a little more complicated. But again, I can't think of a reason why at this point in your math careers where you are going to have to actually manually do such a thing. But it's good to understand. So in this case, I'm going to go this way. But realistically, this is not, hopefully somebody's looking at what I'm doing and you might wonder, why could you not go this way? Because that's 2 dots and there's 2 below and there's 2 above. In my humble opinion, this is a terrible correlation because you do have a positive and negative correlation. So positive correlation, negative correlations. And then in your video today, they call it null, or you could just put no correlation. So that means it has no real relationship to each other. And this is talking about like, let's see, how many miles walked to pounds lost, how many hours studied to grade in class. And then like a no correlation would be the age of your brother and the number of CDs you own. It can happen. And that one's super obvious. But people run studies of things where there's some idea that maybe, or they're curious if it is related. Maybe there is a trend. And so sometimes it just comes out as bad data and there is no correlation to it. And for the students who always ask about when will I ever use this in life? Is this real math? Why do we have to learn this? I think this kind of stuff, is kind of cool because it is real math. And like I used to manage a Sephora and we used to run numbers and like when things were sold and who bought them and things of that nature. This kind of stuff does fall into that for sure. And you start making rules. The word rule is the same thing as an equation. It's just used in a different context. But you would use this negative, positive correlations and no correlations to help make decisions in big business and money kind of things. It describes the goodness of fit of an equation to a set of data. So the correlation, whether it be negative, positive, or null, so obviously null is no good. Positive correlation, that means as our x value, whatever we choose to be our x value or our input, the thing that we can control does cause a positive for the y as well. And then vice versa, as x, whatever our input value, the thing that we are controlling, its dependent variable starts to get negative from that point forward. So the correlation just decides. Now in your calculator, it is denoted by an R and is called the correlation coefficient. And so that would just be some vocabulary stuff. Again, you're not probably going to have to ever write that word out. But the biggest part about Math 1 EOC and Math 1 tests is a lot of it is math you've done before, and it's not like super difficult. Like in this case, you're going to use a calculator, and hopefully, positive is going up to the right and negative is going down to the left, and no line is no line. But it's going to be the vocabulary portion and the sentence structure that's going to stump some of you up, maybe. Okay. So we are going to find a line of best fit for the following data. Because of the system I'm using for this video and to project, I'm going to use my TI-84. I will post a video for you guys later on how to do it in Desmos. It's not hard at all. And again, as a reminder, you will have a calculator on EOC day, and you will have Desmos on EOC day. It's embedded in your test. So it's whichever one you want to get the most comfortable with, or if you want to know both, that's great. So we're going to go to our hit stat, edit, and we're going to go to our list. Sorry, mine are full from our data stuff. And you're going to put your X's in your L1 and make sure you're getting them right, because if you happen to hit a wrong button, just like when you were doing statistics back in the first unit, one number off throws off the whole shebang. So you have, this is going to go in your L1. And this goes in L2. And again, we went to stat and then edit. And then we're going to hit stat, calc. And we are going to go to linear regression. So remember, I did mention that you could have quadratic regressions, cubic regressions, and all of that, like different types of quartic regressions. There's all different kinds, but we're only doing linear regression. So stat calc 4 is the only thing you have to remember at this point. And then depending on which calculator, if they've updated or have not updated, that'll let you know whether it goes, you have to hit enter a lot of times or one time. Because I've had a couple at Pinecrest where it just goes straight to calculate and then you hit enter. Now, so y equals mx plus b, and they just have an ax plus b. So your a is your m. So in this case, we're going to round to the nearest hundredths. So the second place, so y equals 0.98. As a reminder, anything past the number that's 5 or greater rounds the number in front of it up. So it's going to be 0.98x, and then plus our y-intercept, because it's a positive 2. 0.8, and it's in hundredths place, so we'll go 2, and after the 2 is a 0. So now we have our line of best fit. Now, the R value is right there. It gives it to you every time you make a regression. So since our R value is 0.956, and 4 doesn't round up, so we'll go 0.596 or 0.96, the determination whether it is the goodness of fit, so whether it's a strong, weak, or all of those things, determines whether you want to think, is it close to $1, is the way it makes sense to my mind. So is it close to $1? And if it is close to $1, that means it is a strong correlation. So hopefully you already know, you've noticed that the slope is positive. So we know it's going to be a positive correlation by this rule. The kicker is the rule is whatever you did, though. Your calculator can only do what you tell it to do. So in the event you hit a button wrong, or you miss a negative and don't write it down, it could be a negative correlation if you don't tell it correctly. So it is going to be positive. Now, the next question they would ask is, how strong is it? And 96 cents is pretty darn close to $1. So that is a very strong correlation. And so it's a strong positive. The other way you know it's positive is because this number is positive as well, if it happened to be negative. And so when you think about negative correlations, it's still whether it's equal to close to a $1. So -1 would be both ends. So -1 to +1. If it's closer to -1 or closer to +1, is stronger. As it starts to come in towards 0 is when it gets weak. Whether it be on the right-hand side or left-hand side of a number line 0 is just the positive versus negative part. So the next question says goodness of fit. Again, your R value or correlation coefficient is 0.95 or 0.96. And it is, so we're going to call it a strong positive correlation, which means your line of best fit is probably a good rule, because again, this is where that word rule comes in, to make predictions. So this rule will make predictions. This data is not necessarily telling us what it is, but if we had said, you can't really do negative attendance. Off the top of my head, I can't think of anything. But this input value to this output value. If someone was to ask you what would be the predictive value when X was 5, that follows this pattern, then I could plug in a 5 in this X spot, and then I would get a pretty close positive, our output value should be correct and following pretty closely to the pattern of that data that's given to you. Now, I will say when you're making a rule, it's not all, obviously it's not dead accurate. So if you happen to see a scatter plot of the data, you have to pay attention to whether it says what is the actual or what is the predicted. Not huge in Math 1. They don't really get into that a lot. But in your future classes, you will be determining between the predicted and the actual. And the actual are the actual coordinates. And the predicted are the output if I was to plug this in. So if I go to y equals, and I put in 0.98 x plus 2.82, and then, nope, I don't want to do that. Look at my table. So your actual at 2 is 4.78, which is pretty darn close to 5. My actual at 4 is 6.74, which is pretty darn close to 7. My actual at 7 is 9.68. It's a little above 9, but still not like way off in left field relatively. So this would be considered your actual. This would be considered your actual. This would be considered your predicted, because again, that rule is something you made up using your calculator, your Desmos, or your slope and 2 points to make that rule. And I think actually, since I have you guys' attention, Desmos will be easier for this. Can you guys see my calculator okay in your screen, or is it super, super tiny? Okay, perfect. So another way that you can do this, so my y equals, I'm going to leave it there. And because I put my L1 and L2, I can hit second y equals, and I can turn on my stat plot. So hit on. You do want to use the scatter plot, which is shown first. And we're going to use L1, L2, so all of that's set for you. And so make sure all that's good. And then we should be able to graph it. In my window, I probably should set it to 6 is standard. Yeah, there we go. So I have 1, 2, 3, 4, 5 points in my table, and those dots, 1, 2, 3, 4, 5, are the coordinates that I put in. And then you can see, because I typed in the y equals, you have to put it in there to check it and then graph it. You can see that line of fit looks pretty good. And this is a linear correlation of points. It is a positive going up to the right. Again, so all the things. So if you're more of a visual person, this is a way to check to make sure that you pushed all your buttons correctly if you wanted to. Cool part about Desmos is as soon as you put that table in, it starts these dots for you anyway. So not quite as many buttons to push or things to type in on Desmos. So more realistically in the conversation here, so like I said, that this does matter. It is a thing. For conversation of sales and business and all of that. So a local appliance store decided to monitor its sales of DVD players. I don't even know if they do that anymore, but as related to their price. So we have week 1, this is their price and number of DVD players. They randomly chose 5 weeks out of a previous year and obtained data on how many DVD players were sold and the price at which they were sold. This data can be found in the table below. Find the line of best fit. Now, the only thing I would say from this table that could be a little deceiving is what actually matters. We are comparing the number of DVD players to their price. So this whole column right here is arguably just fluff. It is just saying that this was the first week I chose, this was the second week I chose, and so on and so forth. So as far as in your L1, L2, or to write your line of best fit / rule for this data, that column does not matter. So again, if we go back to our calculator, if I hit stat, edit, do hit clear, do not hit delete if you happen to have a calculator. If you arrow up to L1 and hit delete, you lose your L1, which is a whole nother gambit of bunch of buttons and keys to get it back. So when you're clearing tables in your TI dots, use clear. Don't use delete. If you're in down here and you're deleting each one, that's different. But if you want to clear the whole thing, make sure you use the clear button, or you end up in a whole nother, because then you have to change a bunch of things forward or go back in and make it come back. So we're going to put in our 350, 365, 395, 330, 425, So that's all our X values. I have 5 and 5, so I'm good there. 45, 30, 25, 35, and 17. So I have my L1, I have my L2. I double check my values. I'm going to hit stat again, right over to calc. I want a linear regression because that's what we're learning about and we don't have to decide. So linear regression. I am using my L1 and L2 list. If you happen to be in the EOC or something crazy and you delete a list, you can change this X and Y, which you would have to because you're missing one. I don't know which one you're missing if you miss one. But you can change it, and your L1, 2, 3, 4, 5, 6 is down at the bottom of your calculator. So if you hit second 1, you get your L1, second 2, get your L2. You may or may not remember that come that day. But just in case, if you panic, there are ways to get around it. And then so we're going to go all the way down to calculate again. We have our line here. So it's going to be our A value. So Y equals, our A values are slopes, so 0, negative 0.24. Oh, yep, 4, because there's a 9 after the 3. X, and then my y-intercept is plus 119, and we definitely want to do hundreds here because we're talking about money. So we want to use pennies because pennies are part of money. Going 3 decimals out arguably is just depending if you're really trying. Some businesses may do so to prove a point and just for accuracy's sake. But as far as our class is concerned, if it's dealing with money, 2 decimal places after is plenty because that's the logical choice. So it's 575, so it's going to be 58 because the 5 after is going to round it up. Our R in this case, or our correlation coefficient, is negative 0.85 with the 2 after it, so 0.85 is good. At this rate, we have our line. And negative 0.85, again, so strong versus weak versus moderate. So this is our dollar. This is our negative dollar. So this is a strong positive because it's to the positive side. This is a strong negative because it's to the negative side. 0 is going to be weak. Somewhere, and it's a little bit to do with your opinion, kind of where this range is, but about at 50 cents is where I call it. It's still positive, and I call it moderate. And then down here, between 0 and negative 1, it's still a negative 0.5. So it's moderately going to work. It's not great data. I wouldn't give my savings account up for any of that investment or that plan. But it's better than weak. It's not terrible. It's not the worst thing you've ever done. So at this rate, if we wanted to predict how the pricing affects the number of DVDs sold, you could use this rule. So if I wanted to sell a certain number, and again, so back in your calculator, X, Y, which I want to change my window. My Y values are from 17 up, so I'll do Y min positive 10, Y max goes all the way up to 45, so we'll do 50 just to give it some buffer room. Our X values, it looks like the smallest one is 330, so I'm going to do 300. And then I'm going to do my output at 450. My last one, just to get it to show up in our graph. If I graph it, there's our scatter plot. So hopefully you see that it is vaguely going down. It is pretty linear. This plot out here looks pretty far off the rail. Not quite an outlier worthy, but it starts to get a little wiry out here. Once our price. So this price is probably not sticking to the same trend of number of DVDs to be sold usually. And then again, you can go back to your Y equals, and I have my other line in there, sorry. So negative 0.024x, which is what negative 0.24x plus 119.58. And then if I graph it, I see that line going down. It's pretty tight. So as far, again, as that positive and negative would be the up and down. But the strength of the correlation is how close are your points to the actual predicted line. And they're pretty darn close, like I said, except for up here. And that's not out of the norm to be out. Sometimes just crazy things happen in your data sets. And we just have to make sure they're not super crazy. So this would be a fairly strong negative correlation because it's close to a negative dollar. And because we can see in our line, it's pretty close to a straight, like right there where the dots are, and the dots are within reason around it. So it's a strong negative correlation. And again, once you put that equation in here, I could go up to my table and my predicted value, so number of DVDs they were really discussing after 17. They don't have a 20 in our table, so we could assume that if the price is our X value, so we got to get way back up there. Another thing I've had some students in my upper math class, if you have a TI, if you hit second window, tables start, so you don't have to scan for decades. We know that we're up in the 300s up here for our X values that really matter to us. And then your table, we could do it by dollars, or in this case, they're jumping pretty much by fives. So I could change it to fives. So let's say if I went to 325 and let's make our table jump by fives, then we should be able to see these numbers fairly quickly without having to do a lot of scanning. So then I've started 325, here at 330. They said 35. We've got 40. It's not terrible. 335 is not on here, but if we needed to make a prediction, it should be right around 39 to 40 as well. Again, this is your predicted using the rule that we just made up by using our data, and the correlation that we know has proven that it is a pretty good rule. These are your actuals. So you're going to have more predictable values than you will have actual values always. We are running on 2 minutes, so I'm going to wrap this up for this one.